All right, so now that you all have done some research about acids and bases in your project and learned a little bit about the basics, we're going to quickly look over the properties that most of you probably already discovered as you were working. So to get us started off, we're going to work on your warm-up. Take a quick second and we will answer these 4 questions. All right, so what does concentration mean? Hopefully you all told me that it is how much of your solute is dissolved into your solution. So it's telling you how diluted or concentrated it is, how much is present. And then if we look at our pH and pOH, we know that if we add these two together, pH plus pOH, we should get 14. All right, so if my pH is 10, pOH must be 4 because 10 plus 4 equals 14. All right, if our pH is 10, is our solution an acid or a base? The higher the pH, the more basic it is. So pH 10 would be a base. Switching it up a little bit, if the pOH is 10, is it an acid or a base? So we're used to looking at our pH scale, so let's figure out what this would be in pH. If our pOH is 10, our pH must equal 4 so that they add together to give you 14. So this 4 we know would be an acid. All right, so as we take a look at acids and bases, as you should have noticed as you were working through your slides, mostly acids were identified with their H plus concentration. All right, in an acid you have an increased concentration of H plus and a decreased concentration of OH. As you continue to work through your slides and your project and calculate the concentrations, as you worked your way up the pH scale into the bases, you should have noticed that that concentration of OH increased and your concentration of H plus was decreasing. As one increased, the other one began to decrease. So, acids and bases, as we talk about some basic properties. Acids are sour. Most of the things that you listed, lemon juice, Coca-Cola, vinegar, things that are sour tasting. Those are some common household acids that a lot of you all listed out. On the other hand, bases are going to be more bitter and slippery. Think of baking soda, bleach, soap, all things that a lot of you listed in your slides as some example of your household products. Some common laboratory acids. We've worked with hydrochloric acid before in the lab and some other ones as well. So those are some of the most common laboratory acids you'll see, especially as you go into chemistry in college. And then some common laboratory bases. We've worked with ammonia before and so also sodium hydroxide. So these are some things that you've seen before, but we didn't really know much about acids and bases at the time. So now we're going to go into those a little bit more in detail, and tomorrow we'll be able to name those laboratory acids. So when we look at the indicators, you all told me a lot about the different indicators and ways of knowing what substance was an acid or a base. So indicators do exactly what it says. It indicates whether or not something is an acid or a base. Some of the common ones that you all put are the same that are on this slide. We talked about litmus paper and phenolphthalein. That was 2 examples that are the most common. All right, so when we look at phenolphthalein, that is that clear solution that will turn darker pink as it becomes more basic. So if I have an acidic solution here, you're going to see a clear substance. All right, but then as it increases in basicity, all right, so as your H plus concentration decreases and your OH concentration increases, you will see it turn pink. So, as it says, phenolphthalein will be clear for an acid and it'll be pink for a base. So that's your phenolphthalein. If we look at litmus paper, you have 2 different types of litmus paper. You can have red litmus paper, so this is actually a pink color, or you can have blue litmus paper. All right, so if we look at the red litmus paper, if I dip it in an acid, what's going to happen? That red litmus paper is going to stay red, all right? Pretend that's the end that I dipped into the acid. And your blue litmus paper will turn red. So I just say the one way you can remember that is in an acidic solution, if you were to get acid on your hand, what happens? It's going to burn. All right, what color does a burn turn? A burn turns red. So acids are going to turn litmus paper red. If you have a base on the other hand, all right, bases, think base, which is an alkaline solution, so I'm going to write base right here. Base B for blue, all right? So this litmus paper up here, the blue will stay blue, and the red will turn blue. Think B for blue, B for base, all right? So regardless of which color paper you start with, they're going to adjust and change the same. All right, neutral, they're also going to stay their same color, so you'll also see that as well. But when we talk about acids and base, that's how your litmus paper is going to change. So how do you know if something's an acid? Most of the time you're going to see that H plus in front of your anion. Almost all of our acids are going to lead with H plus. That's because that's where you see that increase in H plus concentration in your solutions. So as we're working through these, always associate acid with H plus. All right, and then how do we know if something's a base? You're going to see an OH anion. It's always going to end in OH. So that's where you see that increase in OH concentration in a solution. So as we're talking about base, always associate base with OH. All right. Strong acids. So when we talked about strong acids and strong bases, the strength of it talks about how it disassociates. So the stronger it is, the more quickly it's going to disassociate. What does disassociate mean? It means it is going to break apart. All right, so what happens? Here's our acid, right? Because it starts with the H. Here's that H. Remember we said 2 slides ago, H plus in front of the anion. So what happens is this molecule breaks apart and it's going to donate this hydrogen to H2O. So that's where you see this final product of H3O and your chlorine all by itself. So your acids are going to donate a hydrogen. So it's disassociating and breaking apart. The stronger the acid, the more quickly and the more often it's going to break apart. So when acids and bases react, some of you that use the Proverbs 20:25 verse as we integrated biblical scripture into our analysis of acids and bases, recognize that it talked about pouring vinegar on soda. So if I took vinegar, which is a cleaning product, and I poured it on baking soda, which is also a great cleaning product, what happens? I've poured an acid and a base together. Well, when we pour acids and bases together, it produces water and salt. So your now perfectly good cleaning products are completely ruined, right? We wouldn't want to clean with salt water. So that was the comparison that was being made, was to say it's pointless. We talked about singing songs to those with a broken heart. It's pointless, right? It's not much help to them. So just like it would be to pour an acid and a base together. So that's the comparison that was being made. That type of reaction is called a neutralization reaction. Also, if you think back to Unit 4, that was a double replacement reaction. So that's just a little flashback information. If you see here is HCl, that's your acid, or you can pretend it was vinegar, and then NaOH, there's your base, that would be your baking soda that was in that scripture. And if you see your H and OH come together, and then your Cl and your Na come together, that's your double replacement reaction to produce water and salt. So that's what would happen in that example. So acids and metal, just another quick fact. Acids reacting with metals would produce hydrogen gas. All right, so we did this in one of our experiments when we did the flame test, and we held it into the test tube. And remember, it made that big like snapping sound, really high-pitched squeal for hydrogen gas. So what we had done was we had reacted an acid with a metal to produce hydrogen gas. So how do we measure the pH? How do we measure concentration? That's where we came into our pH scale. increasing acidity as we go towards 0. So the closer to 0 you are, the stronger your acid is. And then the closer you get to 14, the stronger your base is. All right, 7 right here is in the middle. So it gets weak and then stronger, 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 strongest out here at 14. Weak acid, stronger, 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 strongest out here is 0. 7 right in the middle, it's neutral. You have equal amounts of H plus and OH when it is neutral. So that's where you all saw it was 10 to the negative 7 and 10 to the negative 7. Over here at 14, you have far more OH concentration. And over here at 0, you have far more H plus concentration, right? Because acid, we think H plus, and base, we think OH. So when we look at our pH scale, we know that it ranges from 0 to 14. The closer to the ends, the stronger the solution. This was a very common equation that you all used as you work through your project. pH plus POH equals 14. So now we're going to use this equation and we're going to break down some equations, add on going back from concentration to pH and taking our time working through those problems. So a little bit more about the pH scale. It's a scale that shows you the concentration of hydronium ions. It's expressed 0 to 14. As we know, less than 7 is acidic, higher than 7 is basic, and neutral will be right in the middle. So here's a good image that kind of shows you how that pH scale works. So if we have more hydrogen ions on the left and more hydroxide ions on the right, what exactly is neutral? Neutral will be equal amounts of hydronium or hydrogen. Remember we said these two are basically interchangeable with each other as we're talking about acids. And a hydroxide. So you have equal amounts. So example, distilled water. A lot of you for pH 7 used water. Well, if you think about what is water, H2O. You've got a H plus and an OH that it can break apart into, right? H2, 2 hydrogens and an oxygen. So that's what makes water so neutral, is that it can break off and draw a hydrogen or a hydronium ion as well as or a hydrogen ion and a hydroxide ion. Alright, so now we're going to slow down a little bit and talk about calculating your pH and POH values. You did a lot of this during your projects, but we're going to go back now and take it from concentration and go back to pH and POH. Still just as simple, but we're going to take some time and practice through it together. So as you all know, if you know the pH or the POH, you can easily find the other that you don't know, because those two added together should give you 14. So then if you know the pH or the POH, you can easily find the concentration of your hydrogen ion or your hydroxide ion. That's what you all did in your presentation and your projects. And that's what we're going to look at again today, just to kind of review over for any last questions that you may have. So when we talk about pH, the pH is the acidity related to H+. Think H and H goes together. All right, it goes with hydrogen or hydronium. That's where you see the H+. You can also see the H3O+. So don't get confused when you see both of those used interchangeably. All right, this is the new formula we're going to look at today. So now we're going to take the concentration and we're going to go back to pH. And you're going to see that example here in a second. So don't worry, we're going to take some time and work through those. So you're going to use the negative log and you're going to go back to your pH and POH. So pH, and then you have your POH. So POH is the acidity related to your OH concentrations. Remember, OH goes with OH. They always go with each other. OH will never go with H. So this talks about hydroxide, and our formula to go back and forth would be the negative log of hydroxide concentration is going to take me back to my POH. So now that we have kind of taken a quick look at that, we're going to work through some examples so that you can kind of see what we're talking about. So Example number 1. Find the pH if the pOH of a solution is 4. So I know that pH plus pOH equals what? Equals 14. So if my pOH is 4, how do I get to 14? What does my pH have to be? So pH plus 4 equals 14. So my pH would equal what? 10. Pretty simple. That was a lot of what you did in each of your pH slides on your presentation. Now, find the hydroxide concentration, hydroxide meaning OH, if the pOH is 5.4. So one of the important first steps is you need to make sure that this OH matches with this OH. They both have to say OH, or elsewise you're going to have to convert between H and OH, and we're going to look at that next. Alright, so in this case, they're both OH, so I'm good to go. So I'm looking for concentration knowing my pOH. So that's the equations that you all did on your project. So OH concentration is equal to 1 times 10 to the negative pOH. Alright? Because 1 times anything is the same, you do not have to include that 1. Those of you that it may help punch it into your calculator, please do so if it helps you. Otherwise, you don't need it. Alright, so if I know my pOH, all I need to do is plug it in. So, concentration of OH equals 10 to the negative 5.4. Once I plug that into my calculator, I find that the OH concentration is equal to 0.12345 molarity. Alright, so very important here, when you have a decimal in this number, it is no longer a nice and pretty 1. As you can see, when you punch it into your calculator, it's going to give you decimal numbers. You do need to include those numbers. Alright, so anytime you have a decimal in your exponent, it is not going to give you that nice pretty 1 at the end. It's going to give you numbers. Please include those numbers. Alright, so let's take a look at a third example. This time we're looking at the hydrogen concentration. Oh look, it's H plus if my pOH is 8. Do these two go together? Does H plus go with pOH? No. Alright, so that means I need to take my pOH and put it into something that I can use for my H plus. So if I know my pOH plus pH equals 14. So that means 8 plus pH equals 14. So what is my pH going to be? My pH equals 6. Alright, so now I have something that goes with H plus. Yes, awesome. So, how do I get from pH to H plus? Remember, that is your equation. H plus equals 10 to the negative pH. Alright, so what is my pH? My pH is 6, so that equals 10 to the negative 6. Once you punch that into your calculator and move your decimal, you will see that you get 0.0000001 molarity. Alright, pretty simple. This is exactly what you did on your project this weekend and this past week that you've worked on. Alright, so now taking it a step farther into the equations that we just talked about today. Now we're going to go back from concentration and take it back to the pH. Alright, so our equation here was pH equals the negative log of the H concentration. and the pOH equals the negative log of the OH concentration. All right, so find the pH if the hydrogen ion, awesome, H and H, those two go together, I don't need to make a conversion, is equal to 3.25 times 10 to the negative 3. So when I plug this into my calculator, let me change my color so we can see a little better. When I plug it into my calculator, I want pH, and that is equal to the negative log of 3.25. Oh, I don't have enough room to write it here. All right, let's try this. pH equals the negative log of 3.25. And when you punch this into your calculator, remember when we replaced times 10 with an E. Anytime you are putting it in your calculator, you are never giving me an answer with an E, but as you type it into your calculator, you must use E. Must use E. So those of you who still think you're just going to use times 10 anyways, you are going to get the answer wrong. Because there's so many negatives, you must use E. Otherwise, you're going to miss some parentheses that you need. You're going to get the answer wrong. So remember, times 10 is replaced with an E as you punch it in your calculator. All right, so when I type this into my calculator, it gives me a pH of 2.488. All right, so please don't make this any more complicated than it needs to be. Literally, all you're doing is plugging that number into a function in your calculator, and it's going to spit out the answer for you. All right, the biggest thing that you need to do is make sure that these terms match. What you're going to and what you're going from need to match. All right, so let's take a look at this last example here that shows you what to do if your terms don't match. So if we read it, it says pH. If the hydroxide ion, what is hydroxide? Hydroxide is OH. So do these two terms match, hydroxide and OH? No, they don't match. So we're going to need to make a conversion between pH and OH. So I'm going to make a note, pH plus pOH equals 14. Well, the only thing I can do with hydroxide ion concentration is to convert that to pOH. All right, I can easily do this part. So if I say I want the pOH of a concentration, then it's the negative log of the OH concentration. That's what they've given us right here. So pOH equals negative log 7.36. Remember, I need to use E, and then a normal size negative 5. That's how you need to punch it into your calculator. Please do not add any carets. Do not add a times. Do not add a 10. We've done this before. You are not typing in times 10. Times 10 is replaced with an E, as you see right here. All right, so once you punch that into your calculator, you find your pOH to be 4.133. So if that is my pOH, I can now find my pH. So that means pH plus 4.133 equals 14. Once I go and say, what do I need to add to that to get to 14? My pH equals 9.86. All right, so all we did is we did our formula in order to find the pOH so that I could then convert my pOH to pH. All right, so some of the feedback on the Google form said that you all wanted to see some examples in the recordings that were more directly like what you would see on the moms. So I took some of that feedback and I made you all some examples like what you're going to see, the tables to fill in on the moms as you practice these online. So let's look at the first example. I'm filling out the table, and they've given us pH, POH, H plus concentration, and OH concentration. So we know that right off, we know that our H plus and our pH goes together, and our OH and our OH concentration goes together. All right, so what we're going to do is we're going to go back and forth between these in order to fill out the whole table. All you need is one cell of this table in order to be able to find out the other three. So if I'm given the H plus concentration here, then I can get to my pH. All right, so how do I go back from concentration? Remember, that's where we have our negative log of the H plus concentration. So when I take the negative log of this number that you see written here, so negative log of 0.0026, etc., then, and punch that in your calculator, you're going to get a pH of 2.58. All right, if I know my pH, then I can find my POH, because pH plus POH equals 14. All right, so if my pH is 2.8, what do I need to add to get to 14? So in your calculator, do 14 minus 2.8, and you would get a POH of 11.42. All right. Now that I have my POH, I can go over here and find my OH concentration. We know that to find the concentration, I'm going to do 10 to the negative POH. All right, so once I type that in my calculator, all right, I get a value of 3.802 times 10 to the negative 5. All right, so see how I just used what I know, and I went from H plus to pH, then I went from pH to OH by subtracting from 14, and then I was able to go from OH to concentration of OH. All right, so let's look at example 2 here. This time, I'm given my OH concentration, so that means I should be able to go over here and find my POH. So how do I do that? That's when we use our negative log of the OH concentration. So that's the negative log of, and I did punch this whole number into the calculator, but for space purposes, I'm just going to write it out shortened. 9.843. E is how you need to type it into your calculator, negative 5. All right, we've done this before, so please remember you are using E, negative 5. All right, and so once you punch that into your calculator, you should get a value of 4.01, and I did round that off. All right, now that I have this value, I can take it and find my pH, because I know that pH plus POH equals 14. So if I have a POH value of 4.01, I can then subtract from 14 to find that my pH value is 9.99. Now that I have a pH value, I can find my H plus concentration, because remember, H and H goes together. So how would I do that? That's where I'm using my H plus concentration equals 10 to the negative pH. All right, I would suggest you have these written down. It's going to help you because as you're going back and forth, you may kind of get jumbled up with what equation you're on. So just write it down so that you can see when you're using the 10th power and when you're using negative log. So here again, I'm going to have 10 to the negative 9.99 because that's my pH. So once I plug that in and solve, I get a H plus value of 1.023 times 10 to the negative 10th. All right? So then again, see, I went from OH to OH because my OH's go together. Then once I find that, I can convert to pH by subtracting from 14 and then do 10 to the negative pH to find my concentration. So that's what you're going to be doing on the moms. Again, don't overthink it. All you're doing is making those conversions back and forth. Let's look at another example that's similar to what you're going to see on the moms. So now that you have these examples, you can always flip back and see, oh, wait, this is what I need to do. All right, so if you come back to these, you should be able to see exactly what you need as you go through the moms. So acid-base concentration. Remember, we said acids are always corresponding with what? H plus. And bases will correspond with OH at the end. So if I look at this formula that they gave me, it starts with a hydrogen. So that is what? That is my acid or my H plus concentration. So that's what this one wants you to do, is to be able to identify from that formula if this is an acid or a base. Because we're talking about concentration, I know that that is the H plus concentration. Remember, brackets means concentration. So right here, all I need to do is plug in 0.062. Right? Because this is the acid, because there's an H right here, so it is acid concentration or H plus concentration. So now that I have the H plus concentration, I can calculate my pH. Remember, we're calculating pH by doing negative log of the H plus concentration. So negative log of 0.062. And once I plug that in, I'm going to get a pH of 1.21. Now that I have my pH, I can calculate pOH because we know that pH plus pOH equals 14. So 1.21 plus pOH plus a number is going to give me 14. Once I subtract that in my calculator, we find that to be 12.79. All right, your conversions going back and forth from pH to pOH should be the easiest conversion for you to make. All you're doing is subtracting from 14. All right, so now that you have the pOH, I should be able to easily find the OH concentration by doing 10 to the negative pOH is going to give me concentration. So 10 to the negative 12.79. All right, once I plug that in, what do I get? I get 1.622 times 10 to the negative 13th. All right, so that's what you're going to see on your moms for those. Those are some examples that you can flip back to as you're working through these